Good morning, class. I'd like to talk today about transformations. We have some options here. We have rotation, dilation, translation, reflection, and in those four different flavors, we want to discuss orientation, congruency, missing information, algebraic equations, and scale factors if applied. The first problem I'd like to look at is translations. If you're looking at this problem right here, question 1, you see the original and the new. Now, the original would be considered the pre-image, and the new one would be considered the image. I could also label that, if I call this point A, I could call this point A prime, and I'm looking at the point of that house. Now, if I'm reading the question, it says, write the rule for this transformation shown. First of all, it's a slide, because I'm sliding from here, and I'm sliding to here. Now, I just can't slide this way. I'm going to have to go right or left, and I have to go up and down. But I can prove it's a translation because the top is still at the top. It didn't flip, it didn't turn, it didn't get bigger, it didn't get smaller. So if I count my spaces, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm right here. Because if you notice, I'm headed to right here. And if I count down, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So in essence, I went 10 to the right and I dropped down 9. Now if I'm going to write that expression, I'm going to start with x comma y yields. Now I went 10 to the right, so that explains why I added 10 to the x-axis. And I dropped 9 down, and that is my y-axis because y goes up and down. So there is my rule for my transformation. The next problem I'd like to look at is reflection. Reflection means flip. And if you need to remember, it's right there, FL for flip. Now, the problem asks us to write the algebraic representation to describe this reflection. Now, I can prove its reflection by a couple of ways. Number one, to prove its reflection, if I put my hand here and I flip my hand, N would be matching N prime. My Q, which is closest to my x-axis, is still closest to my x-axis. P, which is a little farther, is not much farther, and M, which is very far away, is still very far away. This is reflection. Now, to write the rule for that, you would have to think about what you're doing. First of all, it's always going to have x comma y yield. That's always the beginning. Next, you'll have a parenthesis. Now, the question is it xy? Is it yx? Is somebody negative? Is both negative, positive? The easiest way to test would be to look at an ordered pair. Now, I think I'm going to pick Q, and it's right there, and so is this one. Now, Q itself, I'll need the ordered pair, and Q prime, I will also need that ordered pair. Now, if remember, you go x's first. That's going to be 6 and then going up 1. And Q prime, looks like to me we went right 6 again, but this time I went down 1. Now, if you look at these answers right here, that's my x and y, and this is still x and y, but what happened? Did my x's change? I don't think so. So x does not change. Now, 1 is still 1, but this one's positive and now it's negative. So my y will become negative. Now, an easy way to remember, if you reflect over the x, the y will have the negative. It's opposite. If you're thinking reflecting over x, the x should be negative, you're backwards. If you're reflecting over the x, the y should get the negative. I wrote you a quick reminder. So if you're reflecting over the x-axis, here's your rule. X comma y yields x comma y. They don't flip. But if you're asking about x, the y gets the negative. Now if you're reflecting over the y-axis, same rule. X comma y yield. But if you're asking me about y, then the x should get the negative. Next problem. Rotation. What can we say about rotation? Well, rotation's a turn, and you're like turning the tires on your car. You're rotating the tires to even out the pattern. Now, you can use paper and retrace the shape and then turn that paper and look at it. You can also have your paper in front of you. For instance, here's my math problem. Let me zoom in for you. And I can turn my paper because it's not glued to the desk, and I can look at when I turn it what would happen. But you'd have to keep your eye on the original problem, otherwise you'd be confused. Now, there is another option. The other option would be learn the pattern. Now, if I told you you have the turns are in right angle choices, so you've got one right angle, two right angles, or three right angles, so that'd be 90, 180, or 270. And this is regular clock, the way the clock moves, clockwise. Now, I can undo that and do the other way. Now, to remember that pattern, it's going to be this set of numbers backwards. So if it did 90, 180, 270, it's going to be 90, 180, 270. And these are counterclock. These are equal. More than likely, your test will ask you about the counterclock. Next, I could do x comma y. Yield. Yield means create. Equal sign. Now, the next part's where it gets kind of interesting. So you've got 90, 180, 270. Write that backwards. 90, 180, 270. These are counterclock. Make sure you label them. You've got x comma y yield. Now, you're going to have to remember flip, don't flip. We talked in class about cooking hamburgers and flipping meat and not flipping meat. Maybe you've got the bread here. Maybe you've got the meat and cheese here. So you've pretty much got a hamburger itself. You've got bread, and then something in the middle. But again, flip, don't flip. That means the y and the x-axis would flip places. Don't flip them here. And then again, flip them on the last slot. Now, I can also tell you 1, 2, 1. That means you'll need one negative, you'll need two negatives, and you'll need one more here. And if you look, you have a diagonal running to start you off. So it starts with x, both, y. So 1, 2, 1. That pattern right there will help solve all your rotation questions that you have on these tests. But you have to know how to read this. This is 90% of the work, but the ability to read what you wrote is important. So what does y comma negative x mean? Well, first of all, it means you're going to flip the numbers. And second, it says y sign, positive or negative, would not change, but the sign for x will. So for instance, if you had negative 3, 2, and I did a 90 degree or 270 degree counterclock, they're the same, and use those ordered pairs, what would I yield? Well, I would flip the numbers, so 3 and 2 would be 2 comma 3. This says y doesn't change sign, so if my y is positive, my 2 stays positive, but my x should change. Now x is negative 3, so now it becomes positive 3. And you can write it like that, or you could just write 2 comma 3. Again, the order switches, so I did. The y value doesn't change, so it stays positive. The x value is the opposite of that you have. Negative becomes positive. Again, you just have to read what you wrote. One more. So you have 180 degrees or 180 degrees counterclock. By the way, they're the same. If I gave you ordered pair negative, negative 8 comma positive 10. Well, if you're using your rule up here, it says negative x comma negative y. That means don't change the order, so 810 is still 810. And this says change the sign you have. I have negative, so now I have positive. This one is positive, so I should change it. Now I have negative, and I'm done. And the third one, I'll do one more. You got 270 or 90 degrees counterclock. If I have negative 5, negative 2. If you read the rule up there, it says negative y comma positive x. So you have to flip them, so 5, 2 becomes 2, 5. This says y should change. Now this is my y value, and this one's my x, so it's negative, so it should become positive. And my x value, which is right here, should not change, and it's negative. And that's how you use that table to figure out rotation. I have an example here for you. We can look at this question 4. And so you've got these figures. It says, which transformation best describes this figure? Well, you know it's a rotation because it's turned. It's not any bigger, it's not any smaller, so it's not a dilation. It's not been slid, it's not reflected. It has definitely been turned. So the question is, which one's right? Now you got to remember which one's which. This is the original, and then that's the new one. So this would be A, and this would be A prime. Actually, this side would be. And this would be B. So you've turned it. So you went from the original to the new picture. So you've went that way. And which way would that be considered if I'm using a clock? Well, this way is clockwise. So this way must be counterclock. So if you look at your answer choices, they all say counterclock, so that's a good start. But I went from this quadrant to this quadrant. I only moved one quadrant. So would it be 270, 90, 270, or 90? So I'm thinking more like 90, so the 270s are probably wrong. And if you're looking at your rule and refer back to your personal rule, you went 90 counterclock, which is right here. So it should be negative y comma x. And that is choice J. You will have to write this on your STAR test when you get your test. First thing you do, that way you don't forget. Next, I want to look at dilation. Dilation is the change of size. So you're making it from smaller to bigger or bigger to smaller. And all parts are changing. Now, you're going to change the lengths of the sides, but you would not change the angles because a 90-degree angle is still a 90-degree angle. We don't have a new angle. Now, here's two examples. I want to look at questions 1 and 2. So we'll zoom in on question 1 so you can see that. So there's my question 1. Now, my first question to you is this. Who is first, A or A prime? So if you use your pre-image and image, you should remember A is first, A prime was created. Now, you're going to need to figure out what scale factor was used to make this image larger. Now, you've got enlargement and you've got a reduction. You went from this shape here, ABC, to A prime, B prime, and C prime. So that's an enlargement. Now, in order to find that scale factor, you need to look at a couple of things. You need to look at a length or a width. Don't use a diagonal. It's not user-friendly. Now, I'm looking at the shape, and these are diagonals. These are running across diagonals. But right here is sure nice up and down, nice height. I need to know what that height is. Now, I'll use my highlighter here and I'll help you. I'm looking at that height and I'm looking at that one. Now, if you stop the screen for a second, count those, you'll see a pattern. Now, what is the length of AB? The length of AB is, and yes, you're right, 5. What is the length of A prime, B prime? And yes, again, 10. Now, here's my question to you. If you're going from little to big, so you're saying the little number is 5 times something makes 10. Dilation is strictly a multiplication process. You don't add, you don't subtract, you don't divide. Strictly multiplying. So you cannot change that multiplying sign. And the little one's on this side and the big one's on that side. Says my rule. So 5 times what is 10? And yes, you're correct, 2. Now, what if you didn't know that answer? How could you prove it's 2? Yes, by doing 10 divided by 5. So 10 divided by 5 is 2. Correct. Let's do the next question. Here's my new shape. It's a pentagon. Now the question is, are you making it bigger or smaller? Pick a letter. I picked R. And here's R prime. So this is where you started and this is where you ended. Did you make it bigger? Did you make it smaller? Did you enlarge it or did you reduce it? You reduced it. You made it smaller. So you're going from big going to little. So if you're going to make something smaller, and remember you're still multiplying. Multiplying by a big number won't make it smaller. Multiplying by a big number makes it bigger. So we still need some lengths. You can do a length, a width, a base, a height, but no diagonals. You don't have a lot of options here, so I think you're going to have to use the base. I will highlight that information for you. If you would count, you can stop the screen if you need to. Now, what is the length of the big one? Yes, you're right. The length one, the largest side is 10. 10 times what? And the little one was, yes, again, 4. 10 times what is 4?